Hi class, for example 3, we're just going to be evaluating the shortcuts for the Laplace transforms. So here's a basic idea. Make sure that you have all the shortcuts for the formulas along with the actual definition. And unless they're asking us to evaluate the proper definition, you can use the actual shortcut. So for instance, if they want us to evaluate for part A, the Laplace transform of f of t. So in this case, we're just going to say that, well, the Laplace transform of f of t, it's equal to the Laplace transform of the values of t. And then the formula for t is just going to be technically 1 over s squared for s greater than 0. So this one is just 1 over s squared for s greater than 0. And that's it. So we're pretty much using the shortcut for the evaluation. Let me fix the s. Okay. For part B, we're evaluating a t to the second. So in this case, the Laplace transform of f of t, it's going to be equal to the Laplace transform of a t to the second. And in this case, we're going to be evaluating this formula that technically uses a factorial. So we're going to have 2 factorial on the top. So this is a 2 factorial over the values of s to the 2 plus 1. Let me double check, but that's, yeah, n plus 1. And we end up with a simply 2 over the values of s to the 3rd power. And then technically for the values of s greater than 0. The last one, they're actually combining a couple of actual constants. So in this case, for this particular problem, we're just going to do the Laplace of f of t, which is equal to the Laplace of technically 5 e to the negative 2t minus technically 3 sine of the values of 4t. And what I'm going to do is I'm going to break it up into technically 2 functions. So this is the Laplace of 5 e to the negative 2t plus the Laplace of negative 3 sine of 4t. Now, I'm just going to extract the constants. So in this case, I'm just going to extract the negative 3 and the 5. So we're looking at 5 times the Laplace of e to the negative 2t minus 3, the Laplace of the values of sine of 4t. And then this is going to be equivalent to sorry, I can't erase it. Let me see. So this is just going to be equivalent to the values of 5 times, and then we do have to adjust the part of the e. So on this one, we're going to get s plus 2. So we're going to end up with 1 over s plus 2. And then technically minus 3 times. And then the sine function, the sine carries the k, and then the s squared plus k squared. So we would have a 4 over the values of s squared plus 4 squared. So we end up with a5 over the values of s plus 2 minus the values of 12 over s squared plus the values of 16 for the values of s greater than 0. That's actually it for these problems. The main idea is to apply the formulas for the property of the Laplace transforms.